Okay guys, welcome to CP Chemistry, College Prep Chemistry for this year. This is so exciting. This is something that we're going to be doing new, and I hope you enjoy this flipped classroom as much as I do. We're going to be doing, for your homework, you're going to be listening to the notes and taking notes via me on screen, and then in classroom, we're going to be doing, we're going to be able to open up to all kinds of more different labs and more practice problems, more activities and stuff like that, projects that we're going to be able to do this year in chemistry that we haven't done in years past. So this is super exciting. I am totally excited. So we're going to get ready with our first set of notes, which are the measurement notes. Okay, so each of the notes is going to be numbered, as you see, and it'll have a title on them. So they're easy to find when you're studying for quizzes or tests and stuff. Or if you need to share notes or go back and get look at the notes because you didn't quite understand something. Everything will be numbered and titled. And so these first notes are what we call measurement notes, and we're going to do notes in our notebook, Cornell style. So if you're an avid student or if you're familiar with Cornell style, we're going to do our notes that way. And what this means is that we are going to have a line on our paper dividing the paper into two columns. On the left will be a skinnier part of the paper, which will be for our questions, and then the right side will be for our answers to those questions. So it'll make notes kind of more study user-friendly, in that the questions can be used for yourself to guide yourself in studying. You can ask, fold over your paper, ask yourself the question, then open it up and review all the information that you need to answer that question. Okay, so in these measurement notes, the first question that we're going to ask ourselves is, why do we need to learn to measure objects? Okay, so why do we need to learn to measure objects? You'll soon find out that everything we do in chemistry is going to have some numbers, and so the numbers are going to be measurements, whether it's the number of neutrons or protons in the atom, or if it's how much gas pressure is in the air or exerted on something, or the mass of certain elements or compounds. Everything we're going to do is going to have measurements to it. So the reason why we learn to measure objects is because modern chemistry relies on accurate measurements. We cannot do anything in chemistry without learning how to measure accurately. Okay, so there we have it. Modern chemistry relies on accurate measurements. Okay, so I'm going to flip to the next page, and we're going to talk about, our second question is going to talk about some different systems of measurements, because different countries use different systems of measurements. Okay, in our country here, you'll notice if you're cooking or weighing something on a scale, we have a different measurement system than Europe and most of the rest of the world, which uses what we call the metric system. So we're going to take a look at these two questions, or these two measurement systems, in the next question. All right, so our second question is, what are the two systems of measurement? So here in America we have what's called the English system, and in the English system we have such measurements as foot, inches, cup, ounces, pounds, those kinds of things. Okay. But in the rest of the world, or most of the rest of the world, they have what's called the metric system, or what we call in science the Standard International, or the SI system of measurement. So it's a different system of measurement. It's used more worldwide, and it acts as a common measurement system in science, so that scientists from different parts of the world can use the same measurement system and be talking about the same kind of thing when they're doing their experiments. Nobody has to convert anything or anything like that, so it makes it much easier. So these kinds of measurement units are usually what we see: liters, meters, grams, kilograms, micrometers. All those are what we call the metric system. Okay. So again, we've got the English system used here in America, and then the metric system or the SI system that is used in science, and more worldwide. Cool little arrows there to show you the English system and the metric system. Okay, so we're going to get into, on our next slide, the different kinds of measurements we can make. And some of them are super common. You use them, every day, and some of them not so much. So in our next question, it's going to be the longest question of these notes, is going to be, what kinds of measurements can we make? So a third question, what kinds of measurements can we make? We are going to start with the measurement that you use a ruler to make, and that measurement is length. Okay, so our first one again is the length, and this is the distance between 2 points. When you're measuring length, you're measuring the distance between 2 points. The base unit for measuring length is what we call the meter. Okay, so all these measurements that we're going to talk about today are going to be the metric system of measurements, because that's what we're going to be getting familiar with. That's what we'll be using here in science and chemistry. And so the base unit is going to be meter, which is abbreviated by little m. Okay, and the instruments that we use to measure length are either what's called the meter stick or a metric ruler. And a ruler is metric if it has the side not with inches, but with the little centimeters and millimeter tick marks. If they don't have centimeters and millimeter tick marks, it's not a metric ruler. Okay. All right, so that's our first measurement we can make. The second measurement that we're going to talk about is what's called mass. Okay, mass is the amount of matter in an object. Okay, so whenever we're putting something on a scale or a balance, if you step on the scale in the morning, you are measuring your mass. Okay, how much of you there is. Okay, and so the base unit for mass is grams, and that's abbreviated by the little g. We say base unit because we can add things to these units like prefixes like kilo, milli, centi, mega. All of those prefixes are going to give you kind of a magnitude of how much. So for example, kilo is 1,000. So if we have 1 kilogram, that's the same as saying 1,000 grams or 1,000 base units. Okay, so the base units are always going to be the simplest unit of measurement, and then we can add prefixes onto that to kind of give the magnitude of how big or how little something is. Okay, and so when we're measuring mass, we measure in grams, and the instrument we use to measure mass is the balance or a scale. Okay, all right, so that's mass. Our next measurement that we can make is what we'll talk about is called volume. So our third measurement is volume. Volume is defined as the amount of space an object occupies or takes up. Okay, so how much space it takes up is its volume. The base unit for volume is what we call liters. And so, that measurement is actually kind of crept into our English system here. If you go to the store and you buy some soda, you can either buy it in, the 12-ounce cans, which is English measurement, or you can buy it in, 2-liter bottle, okay, which is the metric measurement. Okay, so our base unit for volume is liters, abbreviated by the capital L. And we can actually measure volume with 2 different instruments, okay? The first one, if it's like a regular solid object, like a cube, rectangle, triangle, whatever, what we can do is we can measure it with a ruler, and then do, your like you learned in geometry, or you will learn in geometry, length times width times height, and get the volume that way. Or if it's like a very fine powder or liquid that doesn't have a definite shape, we can measure the volume of that substance in what we call a graduated cylinder, okay, which you're going to become familiar with in the measurement lab that we're going to do tomorrow, which is, basically it's a tall tube that you can pour liquids or powders into, and it's got little measurements on it. So, or little tick marks to measure things. So those are the two instruments, and depending on the different kinds of objects we have, we can either use the ruler or we can use the graduated cylinder. Either way, it will give us a volume, a volume number that will be equivalent to each other. In fact, the equivalency between milliliters, which we measure in a graduated cylinder, and centimeters cubed, which is what we would measure the metric ruler in, is that 1 milliliter equals 1 centimeter cubed. Okay, so 1 milliliter of something equals 1 centimeter cubed. Okay, those are the equivalents. So if we measure a cube of ice and it turns out to be 1 centimeter cube of ice and we let it melt, we would actually, and we filled that up in a graduated cylinder, it would be equivalent to 1 milliliter of volume in the graduated cylinder. So it's kind of cool. It's kind of an easy conversion to make between milliliters and centimeters cubed. Okay, so that is our third measurement we can make, which is volume. We've got just two more. Like I said, this was the longest part of it, but we can make it. We've got two more, time and temperature. So let's take a look at those. All right, so time is the interval between two occurrences, and our base unit for time is seconds, so we use this on a daily basis as well. Seconds, minutes, hours, those are all with the time measurement. Seconds is the base unit, and anything bigger or smaller than that is beyond that. So the instrument that we use for time is a clock or a stopwatch. All right, so that's what we use to measure time, and so we'll be using stopwatches and clocks if we need to, make certain measurements of time in our labs this year. Okay, so very last one that we're going to talk about is temperature. Okay, so the measurement of temperature. Temperature is the average kinetic energy of an object. And that's kind of weird to think about, but so for example, what you're doing when you measure, if you're sick and you put the thermometer under your tongue and you're measuring your temperature, what you're doing is you're measuring how fast the molecules are moving in your body. Okay, the average kinetic energy, or the average how fast the molecules move in your body, is usually 98.6 degrees Fahrenheit is what we call it. But that's what temperature is. It's the average kinetic energy of an object. So if you are running at a higher temperature than 98.6, it might indicate that you have an infection or something wrong with your body. If you're lower than that, then you can slip into hypothermia, and your body can start shutting down. So it's super important that our bodies run at 98.6 degrees Fahrenheit. But again, that's just the average kinetic energy of the molecules in your body. So it's kind of cool to think about. We'll talk about more with that when we get up to our upcoming units about temperature. Now, the base unit of temperature is degrees Celsius or Kelvin. Okay. So degrees Celsius or Kelvin, and the instrument that we use to measure temperature is a thermometer. Okay, super, super simple. All right, so the very last and probably most important thing that you want to remember when you're making measurements or you're working with measurements in chemistry is that accurate measurements, we always must include both a number and a unit. So must include both a number and a unit. If you measure a number, you gotta put what unit it is. If you're measuring with a ruler, it's gonna be centimeters or meters or millimeters. Okay, it's not just gonna be three what? I don't know, three, whatever. So you have to have a number and a unit, and you're always that unit is gonna drive everything in chemistry. You're gonna see that coming up in the next couple of weeks when we're converting between one unit to another. Okay, units are going to drive everything. So I would even argue to say that the unit is even more important than the number. Okay, so always put your units down when you're making measurements, or if you're working with measurements and practice problems or anything like that. Must put your units. Okay, all right, we've got two more questions in these notes, and they're just kind of some tips for measuring objects, and then we're going to talk just briefly about what a base unit versus derived unit is. So let's do our second to the last question. What are some tips for measuring matter? Okay, so our first tip for measuring matter is for liquids. So anytime you're measuring liquids in a graduated cylinder or a beaker or a burette tube, you're going to follow this first tip. And so the tip is to always read the measurement at the bottom of the meniscus. And the meniscus is the water line in the tube or the beaker. So let me give you an example. Okay, so if this green part here is our graduated cylinder and the blue part is our water line, you'll see that the water line is always bent. Anytime you're looking in a cup, a measuring cup, a graduated cylinder, a beaker, anything that holds water, the line for the water is never going to be flat or straight across. It's always going to be a little curved, and that's because of the cohesive and adhesive properties of water. And so whenever we're measuring liquids, we need to measure accurately by measuring at the bottom of the meniscus. Okay, and so the bottom is, right there. Okay, so we would measure at the bottom of the meniscus. Okay, so in tomorrow's lab, you'll do that exact thing when you're measuring liquids. Okay, the volume of liquids. Okay, our next tip for measuring matter is when you're using scales. Okay, in our labs we're going to be using digital scales, and so the next tip is when you're measuring something, you're never going to put the object or the liquid or the powder or anything like that directly on the scale. That can ruin the scale. So what you'll always have is what we call a weigh boat, a little plastic dish that you're going to put on the scale first, and then you'll put whatever substance you need to measure in that plastic dish. Okay, and so in order to measure just your substance, what you'll do is you will zero the scale with the weigh boat on it first. Okay, so again, for scales, you're going to make sure you zero the scale with the weigh boat on it first before you pour your object, or you put your object on it to measure it. Okay, our last tip for measuring is for using or measuring objects that you're measuring with a non-digital instrument. So nothing that'll just kind of reads it and gives you a number, but you actually have to look at like a scale or tick marks in order to measure it. Okay, so that's going to be our last tip. Okay, our last tip for measuring matter or measuring objects is again, when you're measuring objects with a non-digital instrument like a ruler, a beaker, a graduated cylinder, meter stick, anything that has little tick marks that you have to get the measurement from, you're going to read the measured number plus you can estimate one more digit, and let me show you what that means. Okay, so say I had a ruler here, this purple ruler, and it was a metric ruler. It's got centimeters on it. You can see it's 1, 2, 3 centimeters. And we have this orange, object, this orange stick that we need to measure the length of. Okay, so we can definitely say that on this ruler, it is, 2 centimeters. Okay, but if we take a look, it's not exactly 2 centimeters. It's over 2 centimeters, but we don't have enough tick marks to say it's exactly 2.56 centimeters, okay? But we can estimate that one digit. So instead of just saying 2 centimeters, we can say, looks like it's between 2 and 3 centimeters, so we're going to estimate it to be 2.5 centimeters. So the 2 is our definite measured number, because we know it is 2 something. And then we can also estimate one more digit when we're measuring with non-digital instruments like a ruler. Okay, so we're going to say that this orange stick is 2.5 centimeters. And again, gotta have a number, gotta have a unit. So we have 2.5 for our number, centimeters for our unit. always must have both. Tomorrow in your lab, you're going to do, you're going to be making lots of measurements, and you're going to have numbers, and you're going to have units. If you don't have your unit, you're going to get it wrong, okay? So make sure you always have a number and a unit when you're measuring. Okay, we are going to go on to our very last question for these notes. These are going to be one of the longest notes that we have. Yay, our first notes are going to be long, but stick with me here. We got one more slide to do, and then you'll be done with your homework tonight. All right, we've come to our last question in these notes, and the last question is, what is the difference between a base unit and a derived unit? Okay, because we're going to be working with both kinds of units here in chemistry all year long. So to start with, a base unit is a unit based on a single type of measurement. Okay, so for example, time is just in seconds. Okay, length is in meters. Okay, there's only one unit or one little symbol associated with this base unit. So mass is in grams. These are all base units. So all the ones that we, all the types of measurements that we talked about, length, mass, volume, time, and temperature, are all base units. So again, time, length, mass, these are all single types of measurements. So we call it base units. These are different than derived units. Okay, a derived unit is a unit based on multiple types of measurements. So here's the definition. The derived unit is a unit, again, based on multiple types of measurements. So for example, some derived units are speed. If you're driving in your car and you're going 75 miles per hour down the freeway, miles per hour is a derived unit because it's based on two types of measurements, length and time. Okay, so if we turn it into the metric system, okay, it's meters per second is speed. Again, we have length and we have time. So two different measurements together, okay, make what's called a derived unit. Now, one that we'll be using very, very frequently in chemistry is the derived unit of density. Density is grams per milliliter. Okay, so this is a big one that we're going to be using a lot here in chemistry. Again, two different measurements. We have a mass measurement in grams and a volume measurement in milliliters. So when we combine those, we divide those two numbers and we get density, which is grams per milliliter. This is a derived unit because it's based on multiple types of measurements. Okay, that is the end of these measurement notes. I know that it was long, but hopefully it wasn't too painful for you. And this is the first of many that we're going to have this whole year, so enjoy. We'll see you tomorrow.